Alright, good day to us all. We're going to be looking at displaying quantitative data with graphs today. So we've looked at the categorical, now we're going to look at data that consists of numbers. So after this section, you should be able to do these four things, and we're going to focus on mostly constructing and interpreting dot plots and stem plots in this video. The next video we'll look at this thing called a histogram. But we'll be doing these things, these first two things in this video and the next, describing the shape, comparing distributions, and of course we'd hit the using histograms wisely in the next one. So first thing is we need to know what a dot plot is. Well, a dot plot is a number line with dots representing every data value that we have in our data set. So here's how we make it. We draw a number line, our horizontal axis, and we label it with the variable name. Then we scale this axis from the minimum to the maximum value using a consistent scale from one number to the next. You can't have things spaced unequally on this. That would be a misleading graph. And then we mark a dot above each location on that horizontal axis representing each data value. So here's a quick example. Here's a bunch of goals scored in each game for the 2004 women's soccer team. A dot plot looks like this. We have our number line down here, and we have the number line labeled as the number of goals scored, and then it's labeled our scale, so 0, 1, 2, 3, 4, 5, 6, 7, 8. We're going from 0 to 8 because 8's the maximum, 0's the minimum, and we're evenly spaced on that number line. That's all a dot plot is. It gives us a real easy way to see all of the data right in front of us. When we want to look at the variable on a graph, we want to know, what do we see? What is this showing us? Why do we care? So the way we look at any graph is we should look for a pattern and departures from that pattern. We describe the overall pattern using four things: its shape, its center, its spread, and the presence of any outliers, any values that don't fit the overall pattern. And we can summarize these four things with the acronym SOCS: shape, outliers, center, spread. So don't forget your SOCS when you're working with statistics, guys. SOCS are a good thing. So here we are. We've got a bunch of data for a bunch of cars. We have their miles per gallon for each one. So we have the Acura LR, the Cadillac, the Chevy, Mazda 6, Lexus, Toyota Camry, that's what I drive, Mitsubishi Galant, all these things. We collected the average miles per gallon for each one. And we create a dot plot. We have the x-axis labeled with miles per gallon, a dot representing each one. We want to describe the shape, center, spread of this distribution and talk about outliers. So we are wondering, what are the SOCS for this? So as we talk about this, make sure you're writing it down and making sure you're understanding where I'm getting these conclusions from. So our shape, we can notice that there are some big clusters here. There's a cluster there, there's a cluster there, there's a cluster up there. So what we're looking at is we have some clusters of GPA, or MPG, sorry, not GPA, I'm talking about cars, but we have clusters near 25 miles per gallon, 29 miles per gallon, and 33 miles per gallon. There are also some pretty big gaps down here between them, showing that those are maybe a little bit different kind of cars. So now we're on to outliers. Are there any outliers? Well, there's these two cars right down here. Those correspond to our Rolls-Royce Phantom and our Bentley Arnage, and those are significantly different than the rest. Those things could potentially be outliers. We'll discuss later how to know if they actually are outliers. Let's talk about center. Well, one value we can use for center is the median of this data. And to find the median from a dot plot, it's pretty easy. We just start crossing off dots as we go. I'm trying to find the middle of this distribution. looks like the median value is 28, which tells us that a typical mid-size car in 2009 was getting around 28 miles per gallon. Our spread, we used the spread measurement of the range here to talk about how spread out the data is. So we take the maximum value minus the minimum value. So in this case, 33 minus 14, our range is 19 miles per gallon. That tells us how spread out we are, how much room there is for variability in our data. So let's continue forward. When we discuss shape, we want to talk about whether or not the data is symmetric or skewed. Things that are symmetric, if the right side and the left side are roughly mirror images of each other. We almost never have perfectly symmetric data, especially if it's coming from real data collection. So pretty much always we talk about data being roughly symmetric. Perfectly symmetric would be something, well, here's 3 pictures, but perfectly symmetric would be where we have something like that. If those bars were all the same, left side exactly the same as the right side. Skewed to the right means that there's more stuff to the right. You think of data, these graphs, as having 2 tails going out to the edge. Skewed to the right means that there's a tail extending to the right. Skewed to the left means that there's a tail extending to the left. So this first graph down here is roughly symmetric. We can see that the 2 sides are about the same. Think of it as being a mountain. The 2 sides of the mountain are pretty much the same. There's small differences, but we don't really pay attention to that with actual data. We're expecting that. The second one is skewed left. The left side of the mountain is way longer than the right side of the mountain. And the third graph is skewed right. The right-hand side of this mountain is longer than the left side of this mountain. When we compare distributions, this is where we get a lot of information. We're wondering, how is this group different than that group? And when we compare our distributions, we still think about the SOCS: shape, center, spread, and possible outliers. So here we have household sizes in South Africa and the United Kingdom. And we're going to use our SOCS to compare these. So actually, why don't you pause the video, see if you can identify some things about the shape, outliers, center, and spread, then restart the video and see if what you got agrees with what I'm saying. So for the shape, South Africa is skewed to the right. United Kingdom is roughly symmetric. We can also say that both of these distributions are unimodal, meaning there's one mode, there's one value that sticks out as happening the most. And actually, in both cases, the mode is 4. Outliers, South Africa appears to have 1, possibly 2 outliers, while United Kingdom doesn't. The United Kingdom is grouped much tighter. The center of our data, in South Africa, the median for South Africa is 6, and the median for the United Kingdom is 4. So what we see is that the South African households tend to be larger than the United Kingdom. Our spread for South Africa, our range, is 23, while the United Kingdom's range is 4, meaning we have much more variability between households in South Africa. So that's our basic SOCS overview of this picture, and as we go, we'll learn what to do with those numbers and the conclusions that we can draw.